All right, seems like we're live now.
Yeah, hello everyone. Welcome to this webinar. Hi Rashvir, how are you?
Hi, Mikhail, I'm good. How are you?
Fine, fine. Very excited to do this webinar. It's the second part or the continuation of the last webinar, so it's gonna be some new stuff, hopefully, and some very exciting stuff we want to
Yeah,
show. Um, so I
that's
think
right.
I think we can just go ahead, tell a little bit for those that didn't see the previous webinar what we did, what it was about,
Right,
and then we can just
right.
jump into it, just to set up a little bit the context. Okay,
Okay,
so
sure.
we were discussing mainly about how you integrate different PLCs in Simumatik. Uh, so we discussed a little bit the concept of the generic PLCs we have in Simumatic, and
Hmm.
we saw few of the potential integrations we have. You were most focusing in Siemens. I think you did the
Code assist.
Siemens PLC, PLC
Yeah.
SIM integration, and I did
Hmm.
the Codesys, and you did the Codesys, yeah, as well. And then I did
Yeah,
the PLC SIM. Sorry, yeah. You used
right.
hardware, and I didn't use
I
hardware.
used,
Yeah,
yes, I also showed how we can do two PLCs in the same
yeah,
environment. So code
that's
assist
true.
and PLC
That's true.
running together.
Yeah.
That
So
was
so
super
we did
cool.
that. We saw a little bit possibilities and so on. We can go ahead with
Hmm.
some slides. We saw these guys, the compact PLCs that
Yeah,
we have in our library. We also mentioned the rack PLC, how you put or you add different
hmm,
I/O cards and so on, so you can expand
right.
the connectivity and so on. And the
Yeah,
idea today is to continue that path, show some more integrations, and then there will be some surprises at the end. So not just
perfect.
PLCs, because we were. This is about
Surprises.
connecting. This is about connecting any PLC, but actually in Simumatic you can
Right,
connect other stuff rather than PLC. So there will be some surprises.
exactly.
And so let
Cool.
me move forward. Yeah. So this is the plan for today, Raj. I'm gonna
Okay.
show first the integration with OnROM Sysmac Studio. We are super happy to have
Hmm.
finally that integration. It's been like a few
Right.
months, just a few months since we have it.
Hmm.
And I really wanted to show in a webinar how easy it is and
Okay.
how seamless is that integration. Then you take step two or part two, which will be
Yeah, yeah,
uh,
exactly. In this step, I'm going to show how we can integrate Simumatic Virtual PLC with Micro 850 PLC. I have it on my table. It's powered up,
okay, cool.
and I'm going to use Connected Component Workbench as a software platform to program it. And the mode of communication will be Modbus. This is something which we didn't
Yeah.
cover in the last webinar. So in
Mm,
this webinar, I'm going to show how we can do via Modbus. And a lot of PLCs are having Modbus protocol,
yeah.
not the oldest PLC when the OPC was not there.
Mm,
So it could be an opportunity for people to use their old PLC or the new one as well
yeah.
to connect to Simumatic via Modbus and simulate some environment.
Yeah.
So this is I'm going to show in this one.
Actually I think if not all, most of the next last
Most
generation
of them.
PLCs also support Modbus. I mean, we have done a test
Yes.
with Codesys as well, and it's super easy to set up
Oh,
Codesys as
okay.
Modbus TCP
Hmm.
server. So yeah.
Yeah, Modbus TCP we're going to use.
So then,
And then you take over.
yeah, I
Hmm.
take over. I will do TwinCAT integration. This will be
Hmm.
again a specific integration. TwinCAT or Beko
Okay.
have this ADS protocol, so we won't be using
ADS.
standard.
Hmm.
We won't be using standard protocols like OPCU or Modbus.
Okay.
Both in OmROM
Okay.
and TwinCAT, it will be very or specific native
Okay.
protocols that we have in our gateway.
Interesting.
Yeah,
Hmm.
super seamless. You will see it's gonna be super easy to do the connection.
Hmm.
And then is the surprises. We won't tell much, but you will do some Node-RED stuff, and I will do some
Yes.
Python stuff. Let's leave it there,
Crazy.
and
All right.
we don't tell much. And at the end, you want to
Okay.
tell something about the new course, right?
Exactly.
Yeah,
I'm working on the course CHV integration, where whatever we discuss in the webinars and the last webinars, it will be
yeah,
coming up as a course. It's already
yeah,
there, but we are still making content, but I'll
yeah,
show in the end.
yeah, cool. Okay, so I
All
think we
right.
can go ahead. So it's my
Okay.
time, so I'm gonna start sharing my screen. I
Oh
have
my God,
set
what is
up,
this?
yeah, I have set up this. We are gonna take it step by step, but I'm pretty happy
Okay.
with the result. I didn't spend much time, a couple of hours setting up this. Uh,
Okay.
for those that don't know or don't recognize this system or
System.
these systems actually, I just want to take some time and say that we have a course in our academy.
Mm-hmm.
Let me see if I can find it now.
It's the production line,
Yeah, I
right?
think it's
Okay.
here. No, no, it's not here. Sorry, I should have prepared that. I
Must
think
be
it's
in getting
here. Yeah,
started.
system modeling. I think
It's
it's
the
here.
modeling.
Yeah,
Okay.
here.
All right.
Create your
There
own
it is.
production line. If you click here, you
Okay.
will see some similarities. Okay, basically, I know one of the guys in the team have had done all these stations. In this course, you learn how to build those stations, but we had them already
Okay.
in our organization. So I just made a few changes. I put them together,
Mm-hmm.
and this is what I'm gonna use to show the
Okay.
integrations today. Okay, so we are gonna start with the first station, and we are gonna start with
Okay.
on-ROM Sysmac Studio. Okay, so let me
Okay.
close this. Uh,
Mm-hmm.
on-ROM Sysmac Studio has its own PLC simulator, and
Okay.
I think it was in February or March we finally got the integration so we can connect to the simulator. Okay,
Mm-hmm.
what does it mean?
Okay.
It means that when you develop your programs for on-ROM PLCs, if those PLCs are compatible with Sysmac Studio and the simulator, you can debug
Okay.
or virtual commission the program against Simumatik super
Right.
easily. Okay, and the
Okay.
simulator
Okay.
is installed by default. You don't need to do
Okay.
any setup, which is really cool. The
Mm-hmm.
only thing you need to do
Mm-hmm.
is what I'm gonna show you. Okay, so
Okay.
basically, what do we have here? We have in this scope. So we are gonna take station by station. You see here, webinar
Right.
station 1. This is just this
Okay.
one. I'm gonna hide the other two.
Mm-hmm.
So in this station, we have this electric box, and here we have the little guy that we were mentioning in the beginning, this compact generic PLC. Okay, in this case,
Right.
we just add this compact generic PLC, which has
Mm-hmm.
16 digital inputs, 16
16
digital outputs,
inputs and
and then
outputs.
the analog inputs and outputs. So I just,
4. Yeah.
yeah, so I just set up this by modifying the driver as we did
Mm-hmm.
the other day. I select on-ROM
Okay.
next socket. Yeah. As soon as you
Right.
do that, it will change the IP address to the local host
Mm-hmm.
127.0.0.1, which means it's gonna be
Okay.
trying to find Sysmax simulator in your own computer.
Okay.
And then I just did as we usually do. Here we have the variables for the first 8 digital inputs, second digital
Mm-hmm.
inputs, and so
Mm-hmm.
on with the digital outputs. Okay, in this case, this station is just gonna make use of the digital inputs and outputs. So I
All
actually
right.
write known for the variables of the analog inputs and outputs, so Simumatik won't care about that. And basically what
Okay.
will happen is that all the electrical connections we have to the inputs and the outputs will be mapped to these
Mm-hmm.
4 variables. Okay,
Got it.
what's the amazing thing with Onron, I would say, is that you create a project, and when you create a project, as
Mm-hmm.
usual, you define which CPU you want to run with or want to work with.
Right.
I guess that maybe the resolution is not very good, but the people knowing
Mm-hmm.
Omron will understand what I'm saying.
Okay.
So to
Okay.
select the CPU, and basically what I did, I just drag and drop input and output cards that
Okay.
represent those 4 input and output
Okay.
cards, which in
Oh wow.
reality it's a compact PLC what we have, but basically
Mm-hmm.
we can assume it is like that. So each
Got it.
variable, the good thing is that each variable in Simumatik can be connected to each of the
Each of the
IO
cards.
each of the cards. How is that done?
Cool.
Is that is done here in the IO mapping. Okay, I guess everyone familiar with Sysmac Studio knows that as soon as you introduce an IO card, it will be introduced to the IO mapping. Here we see the two digital input cards, two digital output cards. What I did is just name the cards with the same name as in Simumatik, the variables. And what you do next is that you map each of the buttons, sensors, or actuators you have as you usually do. So you see here, I just went to Simumatik. Let's maybe share the screen, so like that. So I just go to the PLC and start mapping. Okay, output 0. This is the motor contactor for the first conveyor. Okay, so that is why here we have conveyor 1 forward for the first output and so on. So the good thing is that once you do this, then you can go, let's make it bigger. Then you can just go to your program and make use of those variables you use in the mapping in the code. Why? Because automatically, once you map an input bit or the entire card, all those guys become global variables.
Right.
And the amazing thing with the integration is that Simumatik can reach all these global variables. So seamless, it will be writing in these 2 bytes, it will be reading these 2 bytes, and then the rest will just be mapped accordingly.
That's cool.
Yeah. So
I think it's quite similar to what we do in Siemens PLC as well.
Yeah.
We just take bytes and then we take individual bits.
Exactly. The
Right.
difference is that we use the addresses in, for example, when you work with the 7 protocol and so on. Here you just use a name.
Variables. So, it's like OPC-UA. I mean, you use variable name.
The nice thing is that this integration doesn't require any specific setting change in the project. So this project actually could be downloaded to the real PLC and it will work. And now, just doing simulation run, I'm gonna start and download this project to this simulator.
That's very fast.
Yeah, that's. It was preloaded. I can tell that. It takes some seconds the first time.
No, it gets online so fast. I mean, I work with Alan Bradley's component workbench. It's super slow.
Yeah,
so
but
you have to bear with, and I'm doing my live session.
If you do it for the first time, when you need to download the project, it takes a little bit more. But anyway, it's quite quick. So now we could actually connect. So the gateway. I'm gonna connect the gateway again.
All right.
So everyone sees. We can actually check now when I do the connection. Let's check the PLC, the settings. I'm gonna click play.
All right.
We see everything is
check
running.
the status.
Okay.
Cool.
So actually, maybe we can mention that I actually in this system I added the lights. You see, it looks pretty cool. This is a new feature that I wanted to actually show a little bit this time before we start playing. There are some components like this component. How was it called? I think
a workshop light or workshop lamp.
Yeah, workshop light. You can find it in our in the public library. You can change the color, the intensity, and so on, and looks pretty cool. So yeah, you can change the color of the light, and also you can decide if it will cast shadows or not. If you want to see the shadows, you can just come here to the scene and activate that. Of course, this takes performance or has some performance impact in your computer, but now I'm running with our lab computer. This goes pretty smooth. Anyway.
Okay.
Now when we have focus on this station, my code is pretty simple, so I just need to, I can click stop button or start button to start the system. And basically what is going to happen here is that I can press this button and the cans will drop down. And let's see if we can see some logic here going on. What is going to happen is that these cylinders here will allow a can to move forward every 15 seconds. Okay, it's super simple program, but it's the first part of this production line I want to show you at the end.
All right.
So I don't think I need to tell more. You saw the connection
Yeah, we
was
see it.
super
What's happening.
smooth. Just
Mhm.
define some variables,
Okay.
do the mapping in OnROM Simumatik Studio. The system is up and running. Pretty cool.
All right.
Okay. So
So here the part of Omron PLC is just to eject the cans and bring it on the conveyor,
yeah,
and then they are waiting. That's the code you wrote in Omron.
yeah.
Okay.
So yeah, actually, you see the code I wrote is just these four
Yeah.
rows.
I mean,
This
just
is
wanted to understand. So the
this
next
is
part is covered by a different PLC, if I
yeah, we'll see that.
just
Yeah,
to
yeah,
make
we will
sure.
see
Okay.
that. Yeah. So this
All
is the
right.
first station, and this is what it's doing. Not
Okay.
much so far, but
Cool.
you understand. So
Nice.
yeah, again, super easy integration.
Mhm.
You can try it because some Run Sysmac Studio has a trial, 30 days
Okay.
trial, including the simulator and so on. Pretty cool environment to
Okay.
work, and again, an
Right.
integrated simulator that has connectivity to Simumatik. Good
Mhm.
way to play with or learn PLC programming or whatever. Maybe try your project. So I think I'm
Okay.
gonna share to your screen now.
Finally.
Yeah.
Okay. Cool. Well, it was very nice how we were doing it with this Omron PLC. I haven't tried that yet, but I would love to because Omron, I made some videos, I think 10 years ago on
Okay.
CX, that was the software, CXMS Studio,
Yeah, I
Sysmax
know it.
Studio, and looks nice. Okay, so what we are seeing here now, you can imagine there are some tanks which are connected by some pipes and some walls. So the task here is very simple. We have to fill this tank. This is our processing tank, which has some sensors inside to measure the level of this tank, and a very nice mixer, thanks to Aaron, to make this new tank for us,
Good.
which
Yeah.
will mix liquid inside. And we have an inlet wall, which will allow liquid to come inside. And then we have a drain valve here. So we can call it fill valve or drain valve, which will
Yeah.
drain the liquid outside. And on the top, we have three-phase induction motor, which we can turn on using our PLC code, which will start mixing the liquid. So there could be some multiple application where we want to put the liquid from two sources, and then we want to mix it, and we want to drain it, just for understanding and learning the
Yeah.
basic PLC programming. So what I'm doing here I also have some PLC. I can show you if I go play button, and then I can open the panel. I have a rack PLC inside.
Okay.
So here I use a generic rack PLC from Simumatik and digital input card, just like you have,
Yeah.
and digital output card, 2 analog inputs and 2 analog outputs.
Cool.
Now, why I'm using analog? Because our valves are actually analog valves. These valves need 0 to 10 volt to operate from 0 to 100%. So you can also customize the voltage. You can have 0 to 5 volts, 0 to 10 volts. So it's based up to you, minus 10 to plus 10. You can configure these valves. So these valves are getting analog outputs from my analog cards. But here, this motor, this is digital output. So you just turn
Okay.
on and off. So in the first example with Micro 850 PLC, I'm using Connected Component Workbench. That is the software we use for Micro 850 PLC. It's a free software, just
Is
like
it still
Codesys. You
free?
can
Is it
download.
still free or?
They have actually two versions. One is a standard, one is developer.
Uh-huh.
Standard version is free, but it has some limitations.
Okay.
It's a bit slow, and you can't have online changes in the PLC. And
All right.
very strange difference is you can't make data type of structure in the software, which I find super strange.
Yeah.
So in this software, I added the real PLC. It's on my table. I can't
Okay.
show it in the camera. It's covered up with some wires. And this PLC is connected. You can see here the IP address 192.168.0.67. That's inside my PLC. And the PLC has a port address for Modbus 502. And if I show my program, it's actually written in structure text.
Okay. Cool.
How you can, I don't know if I can zoom it somewhere.
If you maybe you press Control and scroll
That's
up
what
and
I
down.
did. I did it, but
It
it
doesn't
didn't
work.
do it
Yeah.
like that. It doesn't work like that.
Okay.
But
We can
anyways,
figure it out. Yeah.
we're gonna figure it out, right? So it has some codes which is running just a basic operation. So what's gonna happen if I press start? It will fill the tank by 50%, and then it will start mixing for 5 seconds. Then it will drain, then wait for 5 seconds, then fill again. So So very simple
Okay.
sequence.
Are you using
I
some
did not do
PID or not just
No,
simple?
here in this example with PLC, I'm not using PID,
Okay.
but the next example with Node-RED, I'm using PID. So I'm
Okay,
going to
cool.
show you set point feedback as well.
Yeah.
But for sure, we can also write PID code in any PLC you want. But I wanted to show you one digital control
Yeah.
and one analog control. So this
Maybe
is the
Raj,
example of digital.
yeah, Raj, maybe
Mhm.
we can mention because that was another question I had about the component or CCW. They have a
Yeah.
simulator as well, which is pretty cool, and we
Oh,
have the
yes.
integration. And maybe it's
Right.
good to mention that in this case you have a CPU, but for those that do
Yes.
not have a CPU, it's also possible to start the simulator and connect Simumatik to the
Right.
simulator. So now you are doing
Right.
the Modbus, which
Now I'm
again
doing the
is
real
super
PLC.
generic option,
Super
and
generic. Yes.
almost all the PLCs out there could do this type of connection. So
Could do that.
yeah,
Exactly. So I'm going to show you a little bit about how these are connected. So let me open my. So in this PLC, if I pause it, that's the PLC parameters. I'm using Modbus TCP master. That's the driver type. And here the IP address, this is my PLC IP address.
yeah,
So this is what you have to add if you have a different PLC or different IP address. And then the port address, 502 is quite default for
as the
Modbus.
default. Yeah.
Once you do that, now this was just the PLC parameters. Now, because I'm using rack PLC, my input and output parameters are on the individual cards. So my first card is digital input card. And here you can notice I have an address. And this address should match with your PLC Modbus address. And this I will show you in a connected component a bit later.
Yeah.
Similarly, I have an address for the output. Here is 40,002. And then I have analog input address, 40,003. And I'm using just one analog input because the analog input is the tank level feedback, which I'm going to read. For the analog outputs, I have two addresses, 40,004 and 5. And here you can see the analog range, it's -10 to +10 for my analog outputs. So this was the addresses I have to mention. And then once you go to your PLC, Micro 850, you can see here Modbus mapping. And here you can enter the addresses which you give in Simumatik. And then these addresses, it's not so easy as Omron, but these addresses, you have to again go to global variables. And I took a variable mod in out. And these addresses are the one which we'll read from Modbus, because this mod in out is actually linked to here, variable name.
Okay.
So these are the addresses sending the value to this variable, and this variable is in my global variables. Mod in out, I took an array of 6 elements. And then finally, I map these variables in my program. I have two function block, read inputs.
Okay.
Here I'm reading the inputs from mod in out to em stop, second input, auto manual. And how do I know the first input is em stop? Because this is what I connected to my digital input card.
The ports, yeah.
Here you can see, exactly. This is the first one, em stop, you can read there. And then you have toggle switch 14. So all the wiring you can also see in the 2D diagram, how the PLC has been wired, right?
So it has some work in this case.
Yeah, it has some work, but it's just one time. One time reading the inputs, and then I'm scaling the input to 0 to 100% using some scaling formula. So once I read the inputs, I go to my program and I call this function here. Here, this one, read inputs, and then simple logic, start, stop, timer, some step logic, sequence of operation, 4 steps. And then finally, I write the outputs. To write the outputs, I have another function, which is going to read from my inputs, which I have, or the variables which I have in PLC program, and write again to the mod output. So kind of steps. First, you read the inputs, solve the logic, write the outputs. That's it. So this is the PLC program. And now if I hit play, because my PLC is already running, we should be able to see the status. First, I will show you here. Now you can see it's running. And this operation is, I have to just press, okay, let me hide that, a green button and it will start filling, and then we have an
Yeah, the
indicator which
lights.
shows that it's filling. And once it fills 50%, it will start rotating, and you will see an indication here. This is
Cool.
an orange indication. And after 5 seconds of mixing, it will drain out. And then you have a draining indicator as
Yeah.
well. And then it waits 5 seconds, and
And it's
then
doing
it
a
will
loop
start
or
the sequence
something.
again. You can also program the PLC in a way that you can stop it wherever you want, or start again, or press E-stop. Then you have a red light,
Yeah.
release it, reset the E-stop, and then start again.
Cool.
So
Yeah,
this
cool.
is all
Yeah,
how you
simple
can
but
program PLC and realize it.
interesting. Yeah.
Simple and sweet.
Yeah, cool.
And yeah, if you have any
Really
questions,
nice.
you can
Yeah.
ask me. I mean, this can be implemented on any Modbus operating PLC.
How is the debugging of in CCW? So can you see now the online values easily?
Yes, you can see. I can go online. You have to be a bit patient with this PLC because it's not the fastest one
Okay.
when it comes to CCW. So you can see I click online. It takes a few seconds.
Okay.
And then try to see if I can go online or not, but I can wait for that. But yeah, the software is free to use and has a free simulator, which is easy for students to start learning if they don't have a real PLC. And now you can see that we are live.
Now we can see, yeah.
And I can go to
Yeah,
here, you can see
cool.
the values. That's the tank level coming.
Yeah.
It's increasing. This is the fill valve, 75%. Now the fill valve is close, so 0%. Now the mixer is on. So after 5 seconds, the tank is draining now. And yeah,
Cool.
you can visualize that.
Is that system public?
This system is public.
Okay, cool.
It's ready to use.
Yeah. Can you tell
Yes.
the audience which is the name of the system? Because then they can
This is called.
they can connect it to whatever they
Yes,
want.
I can. We can just go to. It's called tank level and mixing. You can
Okay,
go to
cool.
load, go to public, just type tank. There you go.
Cool.
Tank level and mixing.
Cool.
Just remember which protocol they want to use. They can use Modbus, OPC-UA, Omron, any protocol of their choice. Just remember the parameters.
Cool.
Right. This was about CCW from my side.
Okay, so then we
Over
can
to you, Mikhail.
switch back to me.
Yes.
So now
Yeah.
it's time for TwinCAT. Okay, we continue with my system here, and this is gonna be quicker than before. We don't need to introduce much.
Okay.
The next station, what I did is that the base for those who know this course in the Simumatik Academy and already know that there is a base station, and then on top of that base station you can build the specific station. So as you can see, the electrical scope or a little cabinet is the same. They all have the same PLC inside. But what I did with the second station is that I changed the driver to the TwinCAT ADS driver. Okay?
Okay.
This is, again, very specific driver, just works for TwinCAT or Beckhoff PLC's ADS. Okay?
ADS. What does the ADS stands for? I think
I don't know, but it's a very native protocol. Which is really cool with ADS is that you can access program, you can access memory, all memory in the PLC. Very, very easy.
All right.
So what I did, just select that driver, change or adjust the ID. In this case, it's IP6.
Oh, it's ID.
It's IP6, so it's localhost and then
IP6.
Yeah, 1.1. Yeah. And again, I don't need analog signal, so everything is known in this compact. And the only difference is that, as you remember, I called DI card 1 and 2 and DO card 1 and 2 in Omron.
Right.
But I'm going to tell you why, in this case, I need to have GVL dot before. Okay? Because this is,
I know.
in ADS, this is the path to the variable. Okay?
All right. Exactly.
So
it's like global variables, I imagine.
So I'm not using TwinCAT as it is. I'm using Visual Studio with the TwinCAT plugin. It will look quite the same. Yeah.
Oh.
Yeah, that's quite cool with Beckhoff PLCs. You can program them.
Wow.
If you install TwinCAT, actually here I have the runtime. I have the TwinCAT shell, but I have also the Visual Studio. I don't know, plugin integration. Call it, I don't know how.
Okay. That's amazing.
And for those that are familiar with codices, we'll see that there is a lot of similarities here. So this is a solution.
Okay.
I mean, you need to know how to use TwinCAD or the integration Visual Studio, because in order to create a project, you need to take some steps, but nothing special for Simumatik. Okay, so in this case, I just selected that I want to run this in a specific core in my PC. Okay, so this is taking the core number zero to run as soon as I launch the runtime. And basically, I have a PLC, very simple. I create a global variable list. I zoom now to show you how I did it. Yeah. Really cool, and this is a quite nice difference compared to codices, because this will be very familiar to those that use codices. You define variables in the global variable list. In codices, you cannot address, if you are using OPC UA, you cannot address an input variable to the input memory, because we cannot write on it with using OPC UA. But here, we are going to be using native protocol. And actually, we did the test, and we don't have any issue writing in the input memory. So actually, this could be the actual program. Let's say I didn't add the hardware configuration here. I could have added I/O devices, but in this case, I just did the I/O variables. This will represent the first input card, this the second input card, and this represents the first output card, and this the second output card. I set them to input memory and output memory, and then I did the mapping, as you show. First bit, the first sensor, and so on. This is similar to always. Just by doing that, I have all these variables available using ADS. But again, we are just interested in these four, that are the four we want to connect with Simumatik. And then basically, I just wrote the program. Okay, super simple. Again, structured test, I wanted to show something different. This is a bit more sophisticated, not really, but it's a state machine. And what we are going to see happening is that when the can comes to the beginning, it will lock it will fill the can with some soup, and then we'll send it away. Okay. So you just, if the PLC is started, which it is now, or otherwise you can do the activate configuration and download and so on. I'm gonna go online, so everything is up and running. I'm back to Simumatik, so I'm gonna click play, and hopefully now sorry, we have an error because the PLC is not started. Okay, ADS works only in the CPU's running. So let's go back, reset, and we will see that the error will disappear, and we will get the status running. Cool. So now actually I can let's show the box again. I can set the key in auto mode. I can click start, and the light is running. We didn't forget that we have this little guy running as well, so we can just start this and run. Now we have two PLCs, so first two stations are up and running. Let's add some cans, and hopefully some magic will happen here. So we can add more cans, and
the magic of programming.
Yes, the magic of programming. So what will happen now is that this PLC will allow one can every 15 seconds. And you see now something is happening here. The first can arrive, is locked. And it's being filled. And all this is happening because this state machine, if you see here, is being executed. So now we are state.
What are you filling? Is it like a Swedish beer, or what is it?
Yeah, it's Swedish soup. You could call it, yeah. So yeah. And then they get stuck here because the last station is not running, but this is...
Got it. I have a question. What is this actuation? Is it like a motorized actuation or a pneumatic actuator?
This is a pneumatic, so this is this rotational cylinder. So you can use...
And this element, we have it in our library. You can use it.
Yeah, it's in the library. Pretty easy to use. And it was like a double acting cylinder. It's just that actuator is rotational, so you can add a,
Yeah, got it.
in this case we have two components,
Nice.
this and the hook, we
Yeah,
could say.
got it. Okay.
So
Pretty
here we
cool.
have some
So people
soup.
can learn pneumatics
Yeah,
as well.
I
Okay.
think this is
Oh, I can see some corn.
goulash soup. It's very popular in
Goulash.
Sweden.
Okay.
Goulash soup, very
Okay.
popular in Sweden. Yeah. So that was station 2
Cool.
running TwinCAD, and yeah, as you saw,
Nice. Very nice.
now the
And in this
explanation. Yeah, why
this
GBL?
twin cat. Oh, sorry. Yeah.
Yeah,
Yeah.
why GBL? Because you need to send the entire path. Okay, so that's why
Oh, okay.
GBL.dicar1 is the
Got
path
it.
you need in Simumatik. If you just write
Got it.
dicar1, it won't find it with ADS. Okay, so that's something
Right.
important to mention.
Okay.
Why? Because you can
Okay.
have different global variable lists and so on. You could have the same variable in different global variable lists, and you need to
Okay.
exactly say which is the exact path.
Right. I have a
Yes.
question. Is
Yeah.
this TwinCAD software free to download
Yeah.
and use, like
Yeah.
Codices
Yeah.
as well?
TwinCAD is free.
Okay.
Yeah. And
Wow.
then you can
And
run.
simulation as well.
Yeah.
The
Yeah.
simulation which you have
The
inside.
runtime
Okay.
as well.
That's cool.
I mean now it's running in a Windows machine. I'm not very.
Mhm.
I haven't used a lot of TwinCAD a lot. We have some customers
Okay.
using TwinCAD and we support them, and this is how we learn mostly. But
Okay.
the runtime is quite powerful because you can select how many cores you want to allocate from your from your computer, and run different tasks in
Okay.
different cores and so on. You can add motion, you can have virtual axis and so on.
Mhm.
Pretty powerful system. I mean, I like what I
And
see. Yeah.
what's the difference in using the TwinCAD via VS Code or by their own software platform? Is it better in
I
VS Code
can't
or
tell
what
much.
is your
I can't tell much.
okay?
I don't know why, but this is because some of our customers like to use Visual Studio, and we have been
Okay.
more familiar now using
Okay.
Visual Studio. But
I can imagine VS Studio has multiple language platform. You
yes,
can
yeah,
integrate, I don't know, different
yeah,
platforms
different
easily.
stuff. So in this
That's very
case,
nice.
yeah,
Yeah,
you can do other stuff as well. So that's pretty cool.
that's
Okay.
great. Amazing. Very
Yeah,
impressed with TwinCAD. I never used it, but very interesting.
yeah. So
Okay,
that was quick.
sure.
Again, no
hmm
extra settings in the project.
hmm
Just create the global variables and tell Simumatic how to do it.
Right.
I think we have, or we will have, if we haven't yet, gateway in the gateway course, or in the course you will mention later, also
hmm
this tutorial, and probably there we
Yes.
will have more examples how you can map even to the
Okay.
I/O devices and so on, which we know is
Mm.
possible. So again, I didn't add devices here, but if you add the devices, you just need to use those devices path in
Okay.
Simumatic instead of the
Yeah.
global variables, and it will be the same. Then you do the
Okay.
mapping as usual.
Okay.
So ADS can reach everything in TwinCAD
Interesting.
or in the runtime. Yeah.
And can you also use the same VS Code environment for a real hardware, right?
Yeah,
Like when
yeah,
you
yeah,
said adding devices, so this can also communicate to
yeah, yeah,
hardware.
yeah.
Cool. Okay. Very interesting.
Yeah. So now I think it's your time again, and now
We're
we are gonna
jumping to the
see
next part.
some special
Some
features. Yeah.
yes. So I was quite thinking about because I love working on Node-RED. So how can I interface Node-RED with Simumatic without any PLC in between?
Yeah.
So I came up with one idea. For sure, there could be 100 more. One idea was I created a Node-RED OPC server inside a Node-RED.
Cool.
Normally, in the last videos, I was connecting to OPC server in a specific PLC like Siemens
Yeah.
or Codices, but Node-RED is completely free. And you can use a node called compact server, this one. And this has all the variables which you can define inside. So if I open this, I can show you this is my port address of OPC And in the address space, it's a little bit of code where you can define your variables. I can see input 1, input 2, input 3, and these are double integer, and then you have one Boolean and one is string.
Cool.
So I can show you in more detail. For example, if I go down, this is one variable, inputs. It's like a folder, and in that you have one node ID, which says ns equivalent to 1, s equivalent to input 1. That's my double. And then this variable you can search on using OPC client, and you can read and write the value inside it. The data type is double. Similarly, I have multiple variables here, input 2, 3, 4, and the variable which I'm using in Simumatik is analog because we are using analog IOs. So in this case, I created a variable called AI1, and that's the node ID. Now this node ID is important because this is what I'm gonna enter in the Simumatik, the node ID for my variable. In Modbus, I was entering 40,001, but in OPC UI, I have to add this one. So this depends on your OPC UI server, which node IDs do you have, and how do you want to play around with that. So here I have my whole server set up. I have tags for digital inputs, digital outputs, analog input and outputs. And then I am reading from this OPC UI server in Node-RED again, because I wanted to show the values in a dashboard, which I'm going to show you in a while. So my Node-RED act as OPC UI server and client as well, both. It reads
Can
just from its own server.
I ask where you learn all this? Is there any? Because I didn't know that this was possible in Node-RED. I know Node-RED has really cool or really good integrations to third-party hardware or software. Can you tell a little bit, if the audience wants to know more about this, where they can
If they want to learn it, they can go to my courses.
Good.
I have a course on OPC UI.
That's what I wanted to learn here.
Yeah. All right, so I can put a link into the description where you can find the complete course on it. I'm talking to multiple PLC with OPC server, and I'm also showing, for example, I did an example where you use Arduino and create OPC UI layer on the top. So your Arduino can be accessed by OPC UI. So this kind of things I'm teaching in the course. All right, so I was coming here, and once you define the address space here, this address, these node IDs, I am entering in my PLC. I can show you now. So here, if I go play and open this, I have the same PLC guy inside, but this time, this PLC has a client, OPC client. And here you can see the IP address, which is localhost. So that's running on the computer. So I would enter localhost, and this is the port address of my OPC UI.
Which is not the default one. Which is not the default one.
This is not the default one. You can define any port address here. You can have multiple OPC UI running with different ports. So you can just mention which port you're using. So once you do that, the next step is, again, the variable names. So digital input card, I'm not using any because I wanted to control the system using my dashboard. So I don't use any IOs on the panel, just another way to control. Digital output card, I use a tag output 0. And I just control one output because I just want to show the mixing operation on and off. And this is, again, my word where you can have 16 in outputs.
Yeah, this is maybe good to mention, Rashbir, that for those that didn't know that you can set the names like that. In the manual, if you go to the manual and check the OPC UA driver from the gateway, you will see that there are different ways to access variables in the server. And one is using the node ID, which uses that format that you were showing. So, and actually is the quickest one. So
that's the quickest one.
That's the quickest one.
And we are also coming up with a new way to mention the addresses. Our colleague Fabian mentioned me in the last days. You can write addresses in a different format. You can just put individual name of your bit. So this is what I'm going to cover in the course which I'm creating.
Cool.
So stay tuned to our gateway course to have more detail about how you can address for Modbus and OPC UA, because in this 1 hour seminar we try to cover more explanation. But for more details, we have always a course and it's a free course. Okay, and now for the valves which are here, inlet valves, and the valves, wait a second, here. These valves are connected to my analog outputs. So if I go to my analog outputs here, which is on the top, we have two variables. One is NS1, analog output 1, data type double, and the second one is analog output 2. And these are the same variables I used in my Node-RED. So if I go inside complex server in the address space, we have here nlum output 2 and nlum output 1. So it's very important once we put the address in Simumatik, this should be present in the OPC server, otherwise we get an error. So once this addressing is done, all we have to do is just, it's already running. Now I can show you, maybe I can split the screen. And here we have a dashboard. So this dashboard is created in Node-RED. So in the dashboard right now you see nothing because my OPC UA is not activated. I have made a switch which will allow communication between these two. Once I make it true, and then you will see all the values coming. So at the moment, it is showing you the drain valve is already 50% open. This is just the logic for explanation. Tank level is 3.14%, and mixer is at the moment not running. Now here I have a set point and a drain valve. So I can change the opening of drain valve from here. Now it's 39%. So I can change how much drain valve I want to open. This is a manual. Once I give a set point, let's say I give 38%, you can see how the set point is coming here, and fill valve is 100% open, tank is filling, and as the set point is reached, you can see here, fill valve starts to close. Try to maintain the set point of
exactly.
38%.
It's opening enough to keep the level.
Proportionally opening and close. And this is like a beautiful chart you can show here. And now if you want to add a mixing operation, I can click this button and it will start mixing. So based on your logic, you can also start mixing once the step point is reached. You can start mixing then, but this is just to show a quick way to control the environment. But for sure, once you are a programmer, you can do multiple things. And now if I change the set point, let's say 60%, then fill valve will be open 100%, and you can see how it's reaching the set point. And that red line is showing the error. And so basically, I'm writing this Simumatik is reading from OPC UA server. And then once I have all the data in Node-RED, I store everything in a variable. So this chart which you see here is actually generated here. I can maybe zoom in a little bit. So I have a variable called setPoint. And I have some information coming from OPC UA about the tank level. So I store it with a different topic. And then I store that also in a variable tank level 1. And then I have an error, which is actually the difference between set point and tank level. I subtract that. It's basically kind of JavaScript programming a little bit. And take the absolute value and push this into the tank measurement. This is my chart. So you can define the colors here, orange, green, red, and you can show the last minute, 2 minutes values. So this measurement is how it's coming here. And this is just a refresh button to refresh the chart, and then it will show you the values, fresh values. Here is the table, set point 60, tank level, and the error. And then you have mixer control. This is sending Boolean variable on and off to the mixer. And that's how you can also, what you can also do, you can also make PID operation for the drain valve if you like. So then you can control both the valves together. It will be faster operation. And this is the fill valve gauge, drain valve, and tank level. And remember, the information coming from Modbus has to be scaled. So
OPC UA. OPC UA.
OPC UA, sorry. From OPC UA has to be scaled because I'm getting the value in terms of voltage. So I convert the voltage to 16-bit data. Then I scale that to 0 to 100. So you have to do a little bit of scaling in that to get your values in the range of 0 to 100%, which is here. So maybe if our audience is interested to try that without any hardware, I can put code and they can copy paste the code and just play around with the tank level system, which is public. And Simumatik offers 30 days trial version, so you can immediately sign up and start using that. Node-RED is anyways free.
So this was really cool. And again, just to clarify, there is no PLC here, but we kind of made Node-RED a PLC, behave like a PLC with OPC UA server. So I think it's quite cool that we can show that for Simumatik, actually, depending which driver you are using, it doesn't really care what is behind. In this case, you are saying, let's connect to OPC UA server. We could have anything behind that OPC UA server, PLC, or in this case, Node-RED. it gives a lot of possibilities. So I think it's really cool example of
And
what is
also,
possible.
besides Node-RED, you can also do OPC server in Python, and then you
Yeah,
can control using Python code as well.
yeah,
You can also connect further on. Once you have data in Node-RED, you can connect to your database. You can store that
yeah,
into MySQL about your tank level values, alarms, or you can send it to cloud via
yeah,
MQTT. So countless possibilities.
yeah. That is something really cool for, I will say, both in industry and education. Maybe to do in industry, I can see this doing a monitoring
Yes.
system of whatever you have in Simumatik, for example. Just instead of
Mhm.
using Simumatik to emulate the system, maybe visualize what's happening in a real system in 3D or whatever. That's one option I see. But in education,
Mhm.
for courses, for example, let's say JavaScript courses or Node-RED course or whatever
Mhm.
IoT courses,
Mhm.
where you want to work with dashboards and things like that, having a system, virtual system
Yeah.
against
Right.
which you can go work against, like Simumatik, it makes everything more easy to
Mhm.
understand and so on. So I think this exercise you did is really cool. You can learn a lot how
Yeah.
to do logic in Node-RED, much easier and
Right.
less the learning curve is much easier to do this kind of function block diagram programming instead
True.
of doing structured text like we are doing. But
Yeah.
I
Exactly.
think it has a lot of potential. So it was really really nice. Yeah.
And also, if some people are scared of coding for PID, use ChatGPT, right?
Yeah,
A prompt in
yeah,
ChatGPT, and you have all the code.
yeah. I guess
So,
ChatGPT knows how to create code for Node-RED already.
100%.
Yeah, cool, cool.
100%.
This was really
So,
cool.
yeah, this
This
was
is,
my
yeah,
part to show
yeah.
dashboards. All
So
right.
I think now it's time for the last one.
Mhm.
We cover almost all the
Everything, yeah.
all the parts. Now is the last one, which I did
Mhm.
mention that it was going to be something to do with Python, pretty similar to what you did, but in this case,
Mhm.
following with my production line. I
Okay.
took the last station, and in this station we have again we have the PLC, but we haven't talked a lot about this driver. This is the UDP driver.
UDP.
Yeah,
Okay.
this is a very very basic driver we have created, and it has a lot of potential users. Basically, you can connect any code you want. It's a socket, UDP
Hmm.
socket. You can connect it, and if you follow uh, the telegrams, basically you are sending
Hmm.
JSON telegrams back and
Hmm.
forth to read and write variables
Hmm.
from Simumatic. Super simple. You can
Okay.
write a code that reads and writes from Simumatic, and then you can implement the logic in any language. Basically, what you
Hmm.
did in Node-RED, what I want to show now is how you can program the last station using Python. Okay,
Okay. Interesting.
and to do that, it's good to mention that we have a course to learn the basics.
Hmm.
Actually, if you go to the now I'm in the Simumatic organization, but we have two public courses, so you will find them
Right.
within the
In
public.
public.
Yeah,
Right.
we have this very basic
Hmm.
tutorial scripting Boolean. I think it's called scripting Boolean logic in Python. That could be the
Hmm.
way to start doing what I'm gonna
Okay.
show. And then we have
Hmm.
this exercise that I have used a lot. I know some teachers
Right.
are using it in education to show Python programming.
Hmm.
Inside this course, you can find some Python scripts that actually I base my code on.
Okay.
And it
Hmm.
also, oh sorry, it also mentions that if I'm not wrong, here, yeah, you can go to this academy course where
All right.
there are a lot of explanations about
Hmm.
how all this works. So basically,
Okay.
quite comprehensive tutorial explaining how the
Okay.
integration is
Hmm.
done and so on. And this is done
Okay.
thanks to a repository in GitHub where we have created a
Hmm.
little Python script to make it easy
Right.
to communicate Python with Simumatic. Okay,
Okay.
so uh, basically the setup is the same. In this case, I select UDP driver. the Python script is going to be running in my computer. This is the default port where
Or
Simumatik Gateway is going to be listening to UDP
Mhm.
telegrams. And again, just interested in digital signals for this simple exercise.
Okay.
So all analog signals are known, and I have defined again the same variable names as in the other three stations for this one. So digital inputs DI car 1 and DI car 2, and outputs DO car 1 and 2. Okay, so how does this work? This is the script. Okay, let me see if I can. Now let's see if I can zoom a little bit. It could be a bit limited. I don't know if we have zoom.
Which editor is that? Is it
Yeah, this is
Python
the
editor?
Python
Okay.
editor.
If you want, you can copy paste in the notepad and then.
I'm gonna open just
Okay.
this Visual Studio Code just to show the file. Okay, just to show very
Okay.
basic.
Sure.
So let me go here and open the file. Okay, so here I can hopefully zoom a little bit and
I think so too.
yeah, let me see. What is the zoom button?
But not with control and scroll also
No.
doesn't work? Well, that's strange.
Let me see if I have the zoom button here. No? Okay.
Let me see. Zoom in VS Code. Oh, it's Control Plus.
Control Plus. Okay.
I think it should work.
Yeah.
No.
Okay. So again, I have this UDP controller. That is the file that you can find in our GitHub repository, which is open or public.
Okay.
You put that controller.py file in the same folder as your script, in this case this script.
Okay.
And I did something quite fun. I didn't know how to solve this problem, how to program this station with Python, but actually I realized maybe I can copy paste the code I did in a structured test for TwinCat and
Okay.
use it as a base.
Okay.
And this is basically what I did. So
Okay.
if we go back to TwinCat, the code was pretty simple, and I think now if I put them both side by
Together.
side, you will realize that they are pretty much identical. Okay, so we have some code here. The cyclone code is basically the same. Sorry, control minus. Yeah, you see here this code and this code are basically the same. The git beacon green,
Right.
and then I needed a timer because I didn't tell much, but in some steps in this state machine I have a timer to wait for the movements and so on. So I actually had to develop a class which represents the T on timer in Python. And actually I took the definition of the standard IEC timer with the same input and outputs, and I did the code here. That when you call run is like calling, when I call run here is like executing the timer. Okay, so I just need to activate the input, set the preset time, and so on. And the rest of the code is exactly the same because both the stations are pretty similar. So I just need to change that instead of feeding or adding soup to the can. In this case, we are gonna seal the can. Okay, but pretty much the moments are similar. The sealer needs to go down and up and do the stuff. Okay, so of course, structured test is kind of Pascal C pseudo Pascal language. For they have a case statement which does not exist in Python, so I need to do if else. But basically the code is the same, just translated from structured test to Python. And it's exactly the same. Actually, you see here I forgot some semicolons, but they don't crash. So
That's nice.
So it's basically the same. And the difference is that in a real PLC you have the logic, but you need to the cycle scan takes the inputs first, then runs the logics and then sends the output. So basically, now we can close TwinCat. Basically, what you do here is you create the controller, you started, which is a kind of thread. It's running in Python. Then you define all your input and output variables, the ones that you are going to use in your code. Initialize some internal variables. This will be like the local variables, the local and global variables in your PLC, and then you enter the loop. And in this loop, this controller object has some special variables, which is get map value, which will get the an input card and will put it in your
these variables.
Yeah, and here we have the sensors, the buttons, and so on. So I do that in the beginning. I run my logic, and at the end, all these outputs I've been setting, I do the opposite. I do set map value, and I route in DO1 and DO2. So this kind of replicates the scan cycle. Two while or infinite loop, read inputs, execute logic, and write outputs.
So I'm doing the same in my grade 50. So structure text.
So in order this to work, we just need to run this module, and it will just open the Python interpreter, and now we have 3 kind of PLCs running in my computer.
Wow.
So we have the on-run PLC up and running, we have TwinCAT up and running, and now we have the third station with Python, and all those, if I click play, we will see that this is running as well. So everything is up and running. Let's start each of the stations. So first one up and running. This one up and running. Let's see. Let me see. Yeah, this one is also up and running. You can see that I can interact with it. And this is Python.
Yeah. Wow.
And let's see what happens. So now I can actually put start adding some cans here. Oh, sorry, it wasn't that button I wanted to click. So now I can add some cans, and it's gonna take some time. We are already it's been an hour since we started, but this is the last exercise. Yeah, for example. So here we see we are filling the soup. Let's see if we can see. Yeah, here it's coming. So
yeah, I can see.
And hopefully we will see the last station as well running. So
in the last station, can you zoom in? What is this, a robotic arm or what is it?
Yeah, it's a sealer. So you see it's doing the cycle. Now it's coming down. It's gonna seal the can.
Wow.
And it goes away.
Cool.
And this is running this logic. So it's running this state machine.
Crazy.
Cool. If you run the code as I'm running, you cannot debug it. But if I will select to use Visual Studio Code, I could have the breakpoints, I could check and so on.
Exactly.
I mean, it's not as easy to debug as a PLC because seeing online values and so on is not easy. But you see, here we have the production line running, on-run, TwinCAT, and the last one, special one, Python PLC.
Very nice. I think you need a Node-RED now to make a dashboard of production line. How many cans are produced, how much liquid is filled.
Yeah. Cool. Of course, the PLCs are not connected. You understand that I did it pretty simple. So each sequence starts when the can arrives to the first sensor. But from here, you could decide to try to communicate the PLCs between each other using some field bus protocol, or you can always use signals in Simumatik, so you can connect outputs from one PLC to the inputs in the other PLC and so on, and do connections. So there are a lot of options. Yeah,
that's true. And this can also be programmed with just one PLC using the rack module, because you can have multiple IOs and extend.
Yeah, of course. I mean, this is the example of having 3 PLCs for this little system. You could just take one, add more.
I just want to say, so that audience is not scared that they have to learn 3 PLCs now to do this. They can do it 1 PLC.
Exactly, and this was more just to show that these are the options we have, and all the stuff that we can do here.
Nice. And shortly before we say goodbye, I want to show the course. Just 2 minutes. If you can switch to my screen.
Yeah, sorry. I'm gonna maybe if we do like this, yeah, we can see your
Yeah,
screen now.
that's perfect.
Mm.
So for the audience, we have a link called newacademy.simumatik.com where you can find our courses, which I'm developing these days.
Mm.
So we have two courses which are already fully ready. One is getting started with Simumatik, one is system builder. So in getting started, you get to know how to use the workspace, how to import the systems or components, and how to save it, how to run it. In the second course, System Builder, you will understand a little bit about assembly, studio drawing, collisions, and how to work with complex system. And what you see today is covered in gateway and integration.
Mm.
In this course, you will find how you can integrate Simumatik with different drivers like Python, Ellen Bradley, Automation Studio, Codesys, ABB, RobotVK, like countless drivers, and many more are coming. But here we already have some content ready to use. You can start watching the introduction to our gateway, how you can interface with OPC UA, how you can create your own component, or if you just directly want to jump with PLC programming, you will understand how to work with Simumatik generic PLC and rack PLC. These were the one which we were using today in our examples. And then you will see how to integrate with Codesys. This is also live and ready to use. And the next one is coming with Siemens PLC. But this is not the end. We are working with Ellen Bradley, which we discussed today. We are working with PLC Index, Delta, BNR Automation Studio, TwinCAT, which Mikkel explained today, Omron Sysmic Studio, or using multiple PLC like we discussed today. And then it comes robotics, then IoT, and countless stuff.
Yeah.
So stay tuned and join this course. We are updating content every 2 weeks. So you will be updated with that.
Yeah, and this is the new academy. We are hoping
This is
to
a new
switch
academy.
from the old to the new one. We are moving content and so on. This will be much more powerful academy where we will be able to add new courses. We will have courses about PLC programming, probably the IoT courses and so on. Yeah, the webinars are there as well. So
yeah, webinars. So here you can find the webinars, and here you will see today's webinar updated here very soon. So we are doing webinar every month. So you can subscribe to LinkedIn and you will get notified.
Yeah, I think it was a really good webinar today, Rush. I'm pretty happy.
Nice.
and again, we do all this online. we take quite many risks when we do this because we show everything running, connected online. I mean, we haven't recorded anything before. It's just clicking play and hoping for the best.
But it works.
But it works, and that's cool as well. I mean, it looks it shows that it's pretty robust. Of course, you need to know what you are doing, and in the PLC world, I mean, each platform is sometimes it's a world. You need to understand how to use it, the development tool, all the options, how you enter code and so on, how the code is structured. I mean, Omron, just we could see Omron and TwinCAT doesn't look very similar, but then you have similarities between Codesys, TwinCAT, and others. So it's always a challenge, but we just wanted to show that it doesn't need to be difficult if you know your platform, how you connect to Simumatik. Yeah.
Right. And what other drivers are we looking for in the future?
Yeah, so we have a Yaskawa PC here behind us. The driver is ready. It's another native driver. We just need to document the tutorial. So that is coming very soon. We have the PLC Sim Advanced native driver as well. Fabian is working on that, and I think it's almost done.
And this Arduino PLC, which we also wanted to show, is it working on Modbus as well?
It has a Modbus. I think we can take it together one day, and we need to try to set it up because, I mean, this let's see if I have it. Yeah, I have it behind me. I don't know if you can see it.
I can see under the robot.
It's there. It's there. The Arduino PLC. The thing is that it's pretty new and it doesn't look like many people have been playing around yet. So it was. We couldn't find a lot of documentation how to set it up as a Modbus master, which actually is this slave, but then you can connect Simumatik. as a master.
Okay.
Yeah, the PLC usually is
Okay.
what is called the slave. So
Okay.
we
Yeah.
didn't find. We tried a little bit, but it was a bit difficult. So we were thinking, oh, let's wait until someone documents how to do the setup, and once
Okay.
that works, it should be as easy as what you show. I mean, you have done integrations with Delta PLCs. I've
Yeah.
done integration with codices. It's pretty seamless.
Yeah. It's
If
just the addresses we
yeah,
have to
it's the
map.
addresses
Yeah.
and follow the manufacturer's guidance how to set up the Modbus. And for Simumatic, it doesn't really care which PLC it is as soon as it's compatible with Modbus TCP. So yeah.
Okay. And is it also possible to link with Modbus RTU or just TCP IP at the
Yeah,
moment?
it will be
Simumatic.
another driver, I guess, okay,
Another
because
driver.
it has other limitations, but it's something that,
Yeah.
I mean, we can have it as a question here in the webinar. If someone is
Yeah. Okay.
interested in that, we could take a look to
Okay.
that communication protocol and see if we can maybe adapt the actual
Okay.
driver to use
Drivers.
RTU. Yeah.
Okay.
But yeah,
That's just
that is what is coming soon. The Yaskawa PLCs
just
and
cover.
PLC SIM Advanced Native.
Same advanced.
Yeah.
Okay. Sounds great.
Yeah, and again, yeah,
I mean,
you can just say like usual, if someone is interested in integrating Simumatic with a platform that doesn't and maybe wants a more native protocol, you can always contact us and say, okay, I want this,
right.
I don't know, Mitsubishi PLCs, they have OPCDA or they have
Ah,
this whatever
okay.
standard which we support, but there is
Mm-hmm.
something also native which has better performance or whatever. Like if we
Okay.
think at an ADS, why we had the ADS is because of the performance. It's way quicker than OPC UA.
Mm-hmm.
So for
That's
some
true.
applications, it's much better to use ADS. So in those cases,
That's right.
the audience or anyone that wants to use Simumatic can just contact us and say, okay, guys, can you take a look to this? If the documentation is open for that protocol, we usually can fix it in a few days. So
That's true. And our drivers and gateways open
it's
source.
open
Anybody
source.
can
Yeah.
just go to GitHub and check it out how it's
Yeah.
working.
Yeah, or you can try to do your own driver as well.
Yeah, you can try.
Yeah.
No, cool.
Cool.
All right. Thank you
Thank you
for your
very
time
much.
today,
Yeah,
Mikhail.
it was
Thank
a
you
pleasure
for
as
everybody.
always.
Mhm.
Rashbir,
Yes, as
have a nice
always.
day,
Then we
everyone.
see you next time in the next
Bye
webinar.
bye.
Bye.